Until now, we have been estimating limits by using tables. It is now time to learn how to solve limits algebraically. Let's look at the limit we solved in the first lecture, f of x equals x squared minus 1. We recall that as x approaches 0, f of x approaches negative 1. You probably noticed already that just as entering 0 for x would have yielded this answer as well. And you're right. In fact, this usually works. But then, sometimes it doesn't. When we look back at our step function, entering 2 for x gives an answer of 3. And we know from the directional limits lecture that the limit doesn't exist for this function. And there is another common case where entering the value of x simply doesn't work as well. Consider the piecewise equation shown up above. If we enter 2, then the function equals 14. However, the function clearly approaches 16 from both sides as x approaches 2. So in this case, what is the limit? Recall that the limit is the value as you get infinitely close to 2. We would never actually reach x equals 2 when evaluating the limits. So for this case, the limit equals 16 even though the function at 2 equals 14. So even though solving the limit algebraically is very quick, it isn't always accurate. With a little practice and familiarity with different functions, you can probably guess when it's not. Let's practice on our hyperbola to get the hang of this. First, we will find the limit as x goes to 0. Evaluating algebraically, we enter c for x. Doing so gives us a 0 in the denominator of the fraction, which we know to be undefined. This means the limit as x approaches 0 doesn't exist. Now let's find the limit as x goes to 1. 1 divided by 1 equals 1. The curve looks smooth, so we can trust that this is also correct. Therefore, the limit in this case does actually equal 1. And that is all there really is to limits. Hope you enjoyed this lecture from freeacademy.com. Please visit our website for more lectures and to support free education.